Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, I will be solving another 5 problems on these are what problems to form linear equation based on real life statement. This is set number 3. This video uh, is from the chapter of linear equations in two variables. And this video is part of the playlist CBSE Maths for class 9 following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the first problem says that the age of a boy is 1/3 the age of his mother. If the present age of his mother is x years and age of the boy after 13 years is y years, then write the linear equation in x and y. So first, it is crucial to understand what the variables x and y are representing. The variable x is denoting the present age of the boy's mother, and the variable y is representing the age of the boy after 13 years. Okay, and what is given? It is given that the fact that is given is the age of a boy is 1/3 the age of his mother. Okay, so okay, so we know y years is the age of boy after 13 years. Okay, so what will be the age of his mother after 13 years? When we know that the age of mother is present age of mother is x years. So age of mother after 13 years will be x plus 13, and and we know age of boy after 13 years is y years. That is what it is given. That is what the variable y is representing, the age of boy after 13 years. Now the age of a boy is 1/3 the age of his mother. So at any moment of time, the age of a boy will always be 1/3 the age of his mother. So the age of mother after 13 years, which is x plus 13, this should be 3 times the age of the boy after 13 years, that is y years. So we can say that, or in other words, we know that the age of the boy is 1/3 the age of his mother. So we can say, so after 13 years also, the age of the boy will be 1/3 the age of the mother. So we can say y, which is the age of the boy after 13 years, will be 1/3 the age of the mother after 13 years. 1/3 of age of the mother after 13 years, which is x plus 13. Now off operator is multiplication. So this is x plus 13 by 3. So we got the equation y equals to x plus 13 by 3. This doing cross multiplication, we have 3y is equal to x plus 13, or the equation in the standard form in the variables x and y will be x minus 3y plus 13 is equal to 0. So this is the linear equation between the variables x and y. If you see any kind of mistakes in my calculation, or I am applying the concepts incorrectly, then please feel free to let me know in the comment section. I will appreciate that. And also, if you have any question, any query about the concept I am applying, if you do not understand any step in any of the problem that I am solving, then also please let me know. I will do my best to assist you. Let's see the next problem. When 4 times the larger of two numbers is divided by the smaller, the quotient and remainder are 10 and 2 respectively. Form a linear equation in x and y if they represent the smaller and the larger number respectively. So variable x is representing the smaller number. X is the smaller number, and the variable y is the larger number. Now from the remainder theorem, we know that if I if I now if I divide, obviously these numbers x and y, since it is talking about quotient and remainder, obviously the numbers x and y should be integers. Now, so when 4 times the larger of the two numbers is divided by the smaller, okay, so 4 times the larger number will be 4y, and if I divide this by the smaller number, which is x, this should be equal to, it is saying that the the quotient and remainder are 10 and 2 respectively. So when I know that if I divide a number a by a number b, and if the quotient is q and the remainder is r, I get, so when I am dividing a number a by a number b, and I have quotient q and remainder r, I know the bigger number a will be equal to the quotient multiplied by the divisor, that is b, plus the remainder. In this problem, the quotient is given as 10 and the remainder is given as 2. Okay, so obviously in this a is the larger number and b is the smaller number. So we must have the larger number. Now remember that we are dividing 4 times the larger by the smaller number. So we must have 4y, y is the larger number, 4 by y should be equal to the quotient, which is 10, multiplied by the smaller number, which is x, plus the remainder, which is 2. So this is very simple. This is 10x plus 2. So we got the linear equation between y and x. Now in the in the standard form, this will be 10x minus 4y plus 2 is equal to 0. I can factor out 2 from the LHS whenever possible. I think it is recommended that if you have a linear equation in two variables in the standard form, always try to factor out any, if any, from the LHS and cancel that, and divide by that factor both the side. So I can factor out 2 from the LHS and I will have 2 into fx minus 2y plus 1 is equal to 0, and then I can divide both the LHS and RHS by 2 and I will have the equation 5x minus 2y plus 1 is equal to 0. So this should be the linear equation in the variables x and y, where x was the smaller number and y is the larger number. Let's see the next problem. Question number 3. The present ages of a father and his son are x years and y years respectively. After 8 years, the ratio of the ages will be 13:8. Form a linear equation in x and y. Okay, so the present ages, x is denoting the present age of the father and y is denoting the present age of his son. Okay, after 8 years, so after 8 years, age of father will be equal to x plus 8, because x is the present age of the father. Similarly, after 8 years, age of son will be y plus 8, because y is the present age of the son. Okay, now the fact is given that after 8 years, the ratio of the ages, that is the ratio of the age of father to the ratio of son, is 13:8. So we must have x plus 8 is the age of father after 8 years is to y plus 8, which is the age of his son after 8 years. This should be equal to 13:8. Applying the concept of ratio, this is nothing but x plus 8 divided by y plus 8 is equal to 13 by 8. So doing cross multiplication, we have 8 into x plus 8 is equal to 13 multiplied by y plus 8. So this implies 8x plus 64 is equal to 13y plus 104. This implies bringing everything to the left hand side, that is the equation in the standard form, will be 8x minus 13y minus 0 minus 40 is equal to 0. So this is the linear equation in the variables x and y, where x denotes the age of the father, present age of father, and y denotes the present age of his son. Let's see the next problem. Question number 4. In a two-digit number xy, where x and y are non-zero digits, if the digits are reversed, the number is reduced by 27. Form a linear equation between x and y. Okay. So the number is x and y. Clearly, x is the digit, x is the tens digit, and y is the units digit. So the number in the expanded form will be 10x plus y. Okay. Now it is saying that if the digits are reversed, the number becomes yx, or in the expanded form it is 10y plus x. So it is saying if the digits are reversed, the number is reduced by 27. So originally the number was in the expanded form 10x plus y, and after the digits were reversed, the number in the expanded form is 10y plus x. So we must have then 10y plus x must be 27 less than 10x plus y. So I can now say that 10x plus y, which was the original number, 24 less than 27, if I reduce 27 from this should be equal to the number of 10 by reversing the digits, which is 10y plus x. Simplifying, bringing everything to the left hand side, I have 10x minus 9x plus y minus 10y minus 27 is equal to 0. This implies this will be not 9x but x, 10x minus x plus y minus 10y. Okay, so we have now 9x minus 9y minus 27 is equal to 0. I can divide both the sides, so I can factor out 9 from the LHS, and I have 9 into x minus y minus 3 is equal to 0. Now I will divide both the LHS and RHS of this equation by 9, and I will have x minus y minus 3 is equal to 0. So this is the linear equation between the digits x and y, between the digits x, which is the tens digit, and y, which is the units digit. Let's see the last problem. The distance between two places A and B is 30 meter. Okay. Rohan starts running from A towards B at a speed of x meter per second, and Avinash starts moving from B towards A at a speed of y meter per second. They meet after 4 seconds. Form a linear equation in x and y. So let's say this is the place A, this is the place B. Let's say they meet over here. They meet at the point C. Okay. The distance AB, so we have this is 300 meter. This is 300 meter. The distance between the points A and B is 300 meter. So Rohan starts moving from A towards B, and Avinash starts moving from B towards A. So the speed of Rohan is given as x meter per second. So the variable x is denoting the speed of Rohan, and Avinash is moving with running from the place B towards A with a speed of y meter per second. So the variable y is denoting the speed of Avinash. Okay. So after 4 seconds, after it is given after 4 seconds, they meet at the point C. After 4 seconds. So definitely Rohan must, in 4 seconds, Rohan must have traveled the distance AC, and in 4 seconds, Avinash must have traveled the distance BC. Okay. So so in 4 seconds, distance traveled or distance covered by Rohan will be equal to the speed of Rohan multiplied by the time, that is 4, this much meter, which is 4x meter. Okay. Similarly, in 4 seconds, distance covered by Avinash will be equal to his speed, that is y meter per second, multiplied by the time. This is 4 into y, 4 into y into 4 meter, which is 4y meter. Okay. So clearly we must have, so this is 4x meter is equal to AC and 4y meter is equal to BC. So the distance, the sum of the distances traveled by Rohan and Avinash must be equal to the distance between the places A and B. So we know AC plus BC should be equal to AB. So this implies what is AC? AC is 4x meter, and BC is 4y meter, and AB is 300 meter. So now we can ignore the unit of meter from both the LHS and RHS, and we get 4x plus 4y is equal to 300. So we get the linear equation between x and y. Again, in the standard form, it will be 4x plus 4y minus 300 is equal to 0. I can factor out 4 from the LHS, and I have x plus y minus 75 is equal to 0. And now dividing both the LHS and RHS by 4, I have x plus y minus 75 is equal to 0. So this is the linear equation between the variables x and y, where x denotes the speed of Rohan, who was running from A towards B, and y is the speed of Avinash, who was running from B towards A, and they met after 4 seconds. So that is all for this video. I hope solving these problems will give you a good idea how to solve this kind of word problems, where you have to form a linear equation based on a real life statement. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Probably the next video I will start coordinate geometry, but I will not really discuss the concepts which are very basic, but I will straight away start solving problems from the textbook, which is probably exercise 8.1, and some problems from the supplementary problems book, that is MCQs in mathematics by RD Sharma. So the next video will be problem solving from the chapter of coordinate geometry. I am ending the video here. Thanks for watching, and until the next video, take care and bye.